Right, we're going to carry on here. Use the periodic table. Right, silver. Silver, this is silver, Ag. You can look that up. Copper, silver, gold. So you'll get copper, silver, and gold. They'll be in one column. The element with an atomic number of 40. That's Zr. Remember, atomic number is the bottom number. So if I said carbon 12, this here is the atomic number. Right. An atom of an element has the electronic configuration 8283. So, right, watch this. I'm not going to draw the nucleus. I'm just going to draw the first shell. I've got 1, 2 electrons. I'm only allowed 2 electrons on the first shell. I have to then jump to the next shell. And I'm allowed a maximum of 8. So I'm going to go 1, 2. I'm just going to draw them in pairs. So it's easy to count. So I've got 8 there. Now I'm going to draw another shell. But on this shell, I only need 3. So I'm just going to go 1, 2, and 3. So the electronic configuration for this is 2.8.3. That means there's 2 on the first shell, 8 on the next shell, 3 on the third shell. This means it's got 3 shells, 1, 2, 3, and you've got 3 electrons on the outer shell. So we're after the group number. And remember what we said. The group number tells you how many electrons on the outer shell. So it's group 3. Explain your answer in terms of atoms' electronic configuration. Right, because there are 3 electrons on the outer shell. Okay, that's it. State the periodic table. Right, because we've got 1, 2, 3 shells, it's going to be in period 3. Remember, period we said is the row. So it's the row, it's in the third row. Right, because there are 3 electron shells. There are 3 electron shells with electrons in them. Right, so it's 2, 8, 3. So let me bring up the periodic table. Right. So it was 2, 8, 3. So we're looking for the third one, yeah? So we're looking for period 3. So look, that's period 1. That there is period 2. This is period 3. Right, so we're looking for group 3. So group 3 on period 3 is aluminium. Because if you add up the number of electrons, 13, it equals the number of protons, because it's going to be an atom, neutral. So we look for the number 13 at the bottom. That's another way of doing it. Right, okay. So it's aluminium. 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 Right, let's keep going. Complete the diagram of fluorine. Okay, so fluorine has got 2, 4, 6, 8, 9. Fluorine has got an atomic number of 9, so it must have 9 electrons as well. Because remember, that's the atomic number, it stands for the number of. And in any atom, protons equals electrons. So we're only allowed 2 on the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. Right, we're not going to bother with these, I decided. I'm going to bother with them, not them, not them, not them, not them. Right, I'm going to go to this one. We're going to come back to those in another topic paper. I don't know why I put them in there. So remember that center bit where all the most of the mass is called a nucleus, and these are electrons, and these circles are electron shells. Electron shells. The particle E is an electron. F is a nucleus. In F you will find neutrons and protons. Okay. Another type of lithium atom has an atomic number 3 and a mass number 4, so 7 and 3. State the name given to atoms with the same atomic number but different. Right, they are called isotopes. Right, we need to draw that. So we're after the electrons. Okay, not the solo. If you just put a ball here and call that lithium for the nucleus, that's more than enough. So we do one electron shell. We're only allowed 2, but we need 3. Because remember, that's number of protons, and it equals the number of electrons. So if you've got 3 protons, we need 3 electrons. We're only allowed 2 on the first shell, and then we go. Yeah, there you go. Right, same thing with this question, right? It's the same relative atomic mass. You put fraction line, you take the mass number 7 times 92.5 plus 6 times 7.5 divided by 100, because they add up to 100. And your answer will be 6.9. That is a 5, by the way. Okay, good. Right, rubidium is an element in group 1 of the periodic table. You've got rubidium, and you've got rubidium. State how the nuclei of 2 isotopes are similar. Right, they both have what? 37 protons. So 1 mark, and that's all they're expecting. Right, state how the 2 nuclei of the 2 are different. So right, okay, they have a different number of what? Neutrons. You don't need to calculate them, it's on 1 marker. How many electron shells are there? Oh, how many electrons on the outer shell of rubidium? Right, so if you look at the periodic table, rubidium, let's bring that up again. So rubidium is here. It's in group 1, so you're expecting 1 electron on the outer shell. Yeah, so it's got 1. Same thing with this now. It's asking for the relative atomic mass. Fraction line. You take no, stop lying. Right, you take this number 85 times 72.2 plus 87 times 27.8. Right, and you should get 85.6. It's a calculator question, so throw that into your calculator. Right, we're not interested in isomers. Right, and we've already done this. Right, see if you can remember this anyway. What's that positive particle called a? What is this one called, the plain one? Yeah. And what's this particle called that runs on an orbit? Right. Electron. Right. The mass number of this atom. The mass number of that would be, just simply add these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Isotopes are atoms that have the same number of, but different number of. And neutrons, there you go. Right, that's all we're doing for this. All these other ones that we missed out, we're going to do in hydrocarbons, hopefully. Right.